So good morning, Dr. Ahmad Gaber.
Good morning. How are you?
I'm good. So it must be very early in Egypt, right?
Yes, it is 4 a.m.
Yeah, so I'm Dewanti and I will be the moderator of this today's conference. And frankly speaking, I am also in France right now. So it's 3 in the morning
Oh,
here.
it's very early. Yeah,
Yeah. So thank
yeah.
you very much for agreeing to be part of this conference, Doctor.
You're welcome. You're welcome. It was my pleasure.
Thank you very much. So good
Yeah.
morning also for Professor Shen. Nice to meet you, Professor. Would you please to unmute yourself because you're still in the unmute mode, so we cannot hear your voices.
So, can you hear me? No?
Yeah, perfect. So good morning, Professor. I'm Dewanti, and I will be the moderator of today. So it's good to see you, Professor.
Nice to meet you. Yes.
So are you in Japan now?
Yes, I in Japan.
So it's around like it's almost noon, right?
No, it's, yes, probably you can say so.
Okay.
It's 11
Okay.
o'clock.
Yeah, 11. Yeah, around 11 o'clock.
Yeah.
So, what topic that you want gonna talk today, Professor?
Yes, I'm recently I'm summarizing my research in Japan.
Ah, okay.
One topic, my research is like urban simulation. So I will introduce my research for urban planning.
Okay.
Actually, I don't have information about university and the conference, but I think the title of the conference is about environmental and sustainable.
A COVID-19 and sustainable development. So you may have a theme on those issues.
So probably it's related to urban planning.
Yeah,
design, right?
yeah. I think we also will talk about in your like a point of view regarding our theme. So it will be fine. So regarding your PowerPoint, is it okay for Dr. Gaber also and Professor Shen to like share after for the participant or how?
Okay, would you like to send it by email or share?
I can send by email if you need.
No, yeah, because normally when we conduct this kind of conference or online webinar, we will send if the speaker is agreed to share their material, we will send, the committee will send to all of the participants.
Okay, I will
along
send
with the certificate.
my PowerPoint. Probably the size is quite big.
Okay. Maybe not now, Professor. It's okay if you want to share it later. Once we finish the session.
Just send now.
Okay.
I'm sending. How to say that? Dr. Irawan?
Dr. Irwan, yeah, to Dr. Irwan. Oh, okay.
I just send
okay.
Now.
Okay. So Professor Shen and Dr. Geber, all of the invited speaker will do the presentation in the breakout room, so we cannot see the participant.
Oh, right.
Yeah. And also we will have a question and answer session after the last speaker delivered the material. So is it okay for two of you?
I'm okay. Yeah.
Okay. Very good morning, Professor Suranto. So, Prof. Suranto, I think you're still in the unmute mode. So, good morning, Prof. Ranto.
Morning, yeah.
It's good to see you again.
Thank you.
Yeah, joining with us already.
In our
yeah, it's a breakout room, Professor. So it's only only invited speaker, and already joining with us, Professor Shen from Kanazawa University, and Dr. Ahmad Gaber from the Port Said University.
Yep. Yeah.
So Professor Shen and Dr. Gaber, let me introduce Professor Suranto. He is the chief of the doctoral program in environmental science, the organizer of this conference.
Good morning, Professor Suranto.
Morning, Professor Gaber.
Yeah. Thank you.
In my department.
Yeah, bam.
Well, I'm happy to have you to help my student to finish his program for PhD. Okay.
It is my pleasure. I'm very happy for this collaboration, actually.
Well, in 2010, I was in Egypt with my doctorate was. Yeah.
Very nice.
Yeah, in a number of universities there. In 3 or 4 universities. Yeah, it was.
Very good. It was in Cairo?
10 colleagues there, rector, vice rector, and then number of dean there.
Yeah.
And we're still going with our agreement, our partnership with a number of universities in Egypt. Yeah.
Very nice.
Well, actually, we tried to invite you to come to my home university a couple of months ago, but unfortunately,
COVID, yeah.
Under unfavorable condition, one day probably, you can go to my home university in Solo, actually.
Inshallah. Looking for that. Yeah,
inshallah, we can go as well in your home university, Port. Said.
You are welcome.
We got 3 universities. It was when we went to Egypt, including the very popular one, especially dealing with the religion.
Azhar University.
Azhar University.
Yeah.
And then it's close to Canal Suez.
Yes.
Yeah.
Suez Canal.
Bisa ngomong kayak gitu.
Morning, Professor Yunus.
Yeah, joining with us also Professor Ahmad Yunus. He is the Vice Rector in Academic Affairs. Good morning, Prof. Yunus.
Yeah, good morning.
Hello. Good to see you, Prof.
Yeah, fine. Alhamdulillah.
Halo,
Prof. Ahmad Gaber.
Good morning, Professor Yunus.
Morning. Yeah.
Nice to see you.
Okay, nice to see you. What about the Egypt now for COVID-19?
Actually, we are considering the second wave. So.
Okay. Yeah.
Actually, we are trying to follow the protocols, and we hope it is possible. Yeah.
And also joining with us, Professor Sajidan, the Vice Rector for the planning.
Morning.
Good morning, Prof.
Morning,
Prof.
Morning.
Yeah, we use the typical clothes Indonesia. We use batik,
Yeah. And actually, it's quite early in Egypt now, Professor. It's 4 in the morning, so.
It is, yeah.
Yeah, 4 in the morning.
Just brighter, Just
yeah.
Before subuh ya?
Yeah. Four, yeah. Just about click after 4, probably.
After 4. After
Correct.
subuh ya? Prior.
How about our speaker from Japan and also Malaysia?
Yeah, just joining with us just for now, Dr. Zulkifli Abdul Karim. Good morning, Dr.
Good morning. Good morning, Ibu.
Okay.
Good morning.
Professor Zulkifli Abdul Karim.
Yes.
Yes.
Correct?
Yep. And Professor Shen also already joining with us.
Okay, Professor Shen.
Yeah.
From Japan, it was.
Correct.
Yeah.
Correct.
Good morning, Prof. Sen.
Good morning. Thank you very much.
Oh, yeah, Prof. Sen. Yeah, good morning, Prof. Sen. What time is it in your country, Professor Sen?
Now is in the morning, 11 o'clock, after 2 hours.
Oh, 11 o'clock. Well, yes, warm enough. Yeah.
Breakfast time in China.
Oh, yeah. Professor Sen from China. Yeah, sorry. Yeah, from China. Yeah.
But he's in Japan for now.
Oh,
now in Japan.
become professor in Japan.
Yeah.
All right, yeah. Xinjiang Sen should be from
China.
Yeah, but already moving to Kanazawa University.
Correct.
Kanagawa.
Kanazawa, Prof.
Yes.
Kanazawa, bro.
Yeah.
Yes.
Kanazawa, ya, Mbak ya?
Kanazawa, Pak.
Kanazawa.
Yeah.
It's Canada. It's almost in the middle of Japan.
Ah, okay.
Yeah, middle of Japan, Kanazawa.
Yes, Kanazawa.
Ini kurang ireng.
So I will remind to all of the invited speaker and also the honorable attendee that we will present and start the plenary session in this break room. So we cannot see the other participant. We're just staying in the breakout room. Okay. And to all of the invited speaker, if you are agreed to share the material, we would like to invite you to send the material maybe to Dr. Irwan, and the committee will distribute the material along with the certificate that will be given to the participant. Okay. And also let me to announce the sequence for the presentation. The first one is Professor Sajidan, and then Professor Zhenxiang Shen, followed by the Associate Professor Dr. Zulkifli Abdul Karim and Associate Professor Dr. Ahmed Kaber, and last but not least, Professor Suranto. And right after Professor Suranto, we will have a question and answer session. So is it okay for all of you?
Yes.
Okay, perfect.
Ibu Dewanti, how long for each presenters?
Basically, maybe it's around, because the time is quite tight, and right after we will have like a parallel session. Maybe it's around like a 20 to 25 minutes.
20 to 25 minutes.
Okay.
Yeah.
30 25 minutes. Okay.
Yeah. So
up to minutes, yes. Okay. Or Professor Sajidan will give probably 15 minutes.
10 minutes, yeah.
Like me.
Enough, I think so.
Yeah. Okay.
Yeah. But it's perfect. Maybe the other speaker will spend like more than that. So yeah, it could be good.
I have some slides to share, so later on you can email to you.
Send to Dr. first.
Yeah,
but we can open our own slide, right?
So each of you, because the committee already assigned you as a co-host, so you can directly share the screen.
Okay, sure.
Share the screen, yeah. So regarding the material, it's not necessarily to send to the Dr. Iwan today, maybe later after you.
Later on, okay.
Yeah.
Sure.
How many participants, Mr. Moderator, Miss Moderator, for Pronehon? The participant is already. What's the number you got already?
Do you mean like the plenary participant or the presenter participant, Prof?
Yeah. You can monitor for that number. No.
Oh, okay. Let me ask because it's like the numbers keep moving,
Yes,
and
sure.
sometimes they who registered, they cannot do like the parallelization or the plenarization. So
Yep. Okay.
in the rough number, maybe like around 100.
All right. Okay.
Yeah.
But do you want the participants come from Indonesia and also from other countries? You know?
Well, we have a number of Rwanda, for example.
Yeah.
Rwanda, and also from a number of overseas. Yeah.
Sudan, I think, Sudan, Rwanda.
Yeah, correct.
Yeah, that's right.
Tanzania, so.
Yep.
Egypt also, yeah.
Egypt, this is the speaker, our friend. Yeah.
Yeah.
So we will be start around in 4 minutes.
Yep.
Professor. Yeah. Okay. So for now in the UNS, the learning is still doing by the online system, Prof?
Yeah, of course. Until
Okay.
the end of semester.
Okay. Because currently I'm graduate from the UNS on 2016 from the Faculty in Economics. Yeah. And now I'm doing my PhD in France. So basically I'm in France now. Yeah.
But at the moment, is it from Indonesia or from France there?
I'm in France, Professor. So
oh,
it's
really?
Yeah, so
it's good. What time is it there? What time?
It's 3 in the morning.
Oh no, 3 o'clock should be.
This is overnight,
overnight. Attached in your, oh no, 3 o'clock. Oh.
No.
You can eat sahur.
Yes,
correct.
Yeah.
And the subuh prayer, it's around like almost 7 in the morning.
Oh,
yeah.
Yeah.
Yeah, it's very late in the winter season.
But sun shining there for 7 o'clock in the morning. Yeah.
No, like the sunrise is around 8.
Oh, around 8. Oh.
Yeah, this is winter time.
Yes,
winter.
It's a winter time.
Session, yeah.
So it's such a big pleasure for me to be part of in this conference and learning from like a reputable scholar.
We're proud of you. Yeah, we're still in France there. Yeah.
Yeah.
I think you are just here in Solo in Tawangmangu or in Bangalore, I think, but apparently it's still from French.
What's your area?
For your dedication, for your institution, UNS. Okay. Yeah.
Thank you,
Prof.
Prof.
Thank you very much. Yeah.
So when you announced that we need to wear a batik on Sunday, I'm just thinking like, okay, do I have a batik with me now? And thankfully, I bring my batik so I can wear it today.
Oh, but if not, you can just ring Professor Sajidan. It will be nice.
Yeah.
Batik day.
And sorry, Dr. Zulkifli, my area is currently I'm working on the Fintech area.
Fintech.
Lending.
Oh, Fintech. I see. Yeah.
It's junior Prof. Pak Irwan, yeah.
Yeah.
He's my supervisor back then.
You're senior alumni from FEB, Professor Bimbo is the host of our nation.
The head of Financial Service Authority, right?
Yeah, that's right. Yeah.
Yeah.
This is graduation from our home university. Yeah.
Correct. So I think we can start now.
Yeah.
Yeah.
Professor?
Yeah.
Oh. Good morning, ladies and gentlemen. Welcome to the first international conference on environmental and sustainability development organized by the Doctoral Program in Environmental Sciences, supported by Center for Fintech and Banking, Universitas Sebelas Maret. I'm Dewanti Chainingsi, and it's such a pleasure for me to be part of your conference as the Master of Ceremony. This conference is intended to provide an international forum for academia to discuss the current issue on environmental and sustainability. And proceed to the first agenda, let's have a brief of moment to sing Indonesian national anthem, Indonesia Raya. I would like to invite all of the invited speakers and also the participants to turn on the camera. So ladies and gentlemen, please turn on the camera. Thank you. Ladies and gentlemen, let me greet the honorable attendee, invited speaker, distinguished discussion, and also participant and the presenter for today's conference. So let me greet and say a very good morning to the Vice Rector for Academic Affairs, Universitas Sebelas Maret, Professor Ahmad Yunus. Good morning, Prof.
Good morning.
And also Vice Rector for Planning and Partnership, Universitas Sebelas Maret, Professor Sajidan. Good morning, Professor.
Morning.
And Chief of Doctoral Program in Environmental Science Program, Professor Surento. Very good morning, Prof.
Morning.
And last but not least, from the UNS board, Chief of Center for Fintech and Banking, Universitas Sebelas Maret, Dr. Irwan Trinugroho. And also the external invited speaker, please welcome Professor Xiang Shen from Kanazawa University, Japan. Good morning, Professor Shen.
Morning, thank you very much.
And Associate Professor Dr. Zulkifli Abdul Karim from University Kebangsaan Malaysia. Good morning, Professor.
Morning.
And Associate Professor Dr. Ahmed Gaber from Port Said University, Egypt. A very good morning, Professor Gaber.
Good morning.
I would like to warmly welcome you to the first international conference in Environmental and Sustainability Development, organized by Doctoral Program in Environmental Science UNS and supported by Center for Fintech and Banking Universitas Sebelas Maret. So it's such a pleasure for us to be part of this conference and having a notable invited speaker to share their knowledge on the theme of today, COVID-19 and sustainable development. So today's conference, we will have two main agenda. The first one is the plenary session, and the second one is the parallel session where the presenter could present their paper and have input and insight from the honorable discussant. So to officially open this conference, let's proceed to the next agenda, welcome greeting and opening remarks. And the welcome greeting will be delivered by the chair of Doctoral Program in Environmental Sciences, Universitas Sebelas Maret, Professor Suranto. So for Professor Suranto, platform is yours.
Thank you, Ms. Moderator Devanti from France. Bismillahirrahmanirrahim. Respectable Vice Rector for Academic Affairs UNS, Professor Ahmad Yunus, all plenary session speakers. Yeah, we have here Professor Sajidan. Yeah, he is actually the Vice Rector for Planning and Partnership UNS. Also, Professor Jinjang Sen from Kanazawa University, Japan. Associate Professor Dr. Zulkifli Abdul Karim from University of Kebangsaan Malaysia. Associate Professor Dr. Ahmad Gaber from Port Said University, Egypt. And all discussion participants of this conference. Assalamualaikum warahmatullahi wabarakatuh. Good morning and selamat pagi.
Good morning.
First of all, on behalf of the Doctoral Program in Environmental Science of UNS, we would like to thanks for your participation in this first international conference on environmental and sustainable development. We are also grateful to all speakers and discussants for your contribution in improving the quality of this conference. There are more than 150 participants, both presenter and non-presenter. This event, which is basically dedicated to facilitating my doctoral student and other scholars to disseminate their research papers. Here we have well-reputed discussants who will criticize and provide input to working paper presented in this conference. Ladies and gentlemen, the Doctoral Program in Environmental Science UNS has established a vision to be a center of education to solve environmental issues based on expertise and to produce graduates with professional competencies in the field of environmental science. Therefore, the quality and dissemination of this research are our concern in this program. In concluding, let us reiterate our sincere hope that this event is worthwhile for you, and also we wish this forum will lead to better outcome of this doctoral program in the near future. That's probably all what I want to say. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the welcome greeting from the chair of the doctoral program in environmental science, Professor Suranto. And now let's have the opening remarks to officially open the conference. And On the representative from the UNS will be delivered by the Vice Rector of Academic Affairs, Universitas Sebelas Maret, Professor Ahmad Yunus. Good morning, Professor.
Good morning.
Platform is yours, please.
Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning.
Good morning.
Salam sejahtera bagi kita semuanya. The distinguished Vice Rector for Planning and distinguished the head of Doctoral Program of Environmental Science, Professor Suranto, the Honorable all plenary speaker, Professor Chen Jiang Sen from Kanazawa University. Good morning, Prof. Sen, and Ohayo gozaimasu.
Good morning.
Honorable Associate Professor Zulkifli Abdul Karim from University.
I think there is a connection problem with you, Prof.
No problem.
Please, yeah.
Yeah, we follow. And the Honorable Professor Ahmad Jabir from Port Said University, Egypt. Good morning. And Professor Suranto from Sebelas Maret University. It is a great pleasure to welcome you on behalf of Universitas Sebelas Maret to the first international conference on environmental and sustainable development, or ICESD. We are indeed pleased that the number of distinguished speakers as well as scholars participate in this particular event. Ladies and gentlemen, first of all, I thank the Doctoral Program in Environmental Science Graduate Program Universitas Sebelas Maret for organizing this conference. As we know, the goal of the doctoral program is to train students at the advanced level in their specific field, especially through conducting high-level research. Therefore, the doctoral student should disseminate their research findings in scientific forum and publish research paper in reputed journal. Publishing paper in the academic journal could also be considered as the extent to which the doctoral research is appreciated by the scientific community in their respective field. I would also like to thank the presenters as well as non-presenter participants for your enthusiasm to participate in this event. My gratitude also goes to all invited speakers who will specifically discuss about recent issues on environmental and sustainable development. We will learn their perspective regarding this particular issue. This international conference is in line with the vision and mission of UNS. UNS is committed to accelerate our reputation and contribution both to the academic and to the society as a whole, not only at the national level, but also in the international environment, as we are fully aware that in today's globalized world, contribution of the university should be promoted to a wider spectrum. In concluding, I wish you very fruitful discussion and hope that you find your participation in this event worldwide. We'll say Bismillahirrahmanirrahim. The first international conference on environmental and sustainable development is officially open. Thank you very much.
Thank you very much for Professor Ahmad Yunus for the opening remark to this conference. And before we start the main agenda of the plenary session, I would like to invite all of the invited speaker and also honorable attendee to have virtual photo session. So let's have the bright smile for today's and really wish that this conference will be run well today. So the committee, are you ready? Let me count into 3, 2, 1 and say cheese, everyone. So 3, 2, 1. Once again. 3, 2, 1. Thank you very much to all of the invited speakers to have the photo session with us. And let's proceed to the main agenda of the plenary session today. Today's plenary session, we will have 5 invited speakers that will share their knowledge and a point of view on the theme of today's conference, COVID-19 and Sustainable Development. So as we know that the COVID-19 outbreak announced by WHO in the end of 2020 bring a lot of changes in how people live. And it's also create a crisis in many areas that need to be addressed by the scholar in any kind of area to how to solve this problem and bring back to like the new equilibrium. And today we will have 5 invited speakers that will share their knowledge regarding to their own research area. And for the first speaker is Professor Sajidan. He is a full professor at the Department of Biology, Faculty of Teaching, Training, Education, Universitas Sebelas Maret UNS. And he holds a PhD degree in bacterial genetic or biotechnology from Humboldt University, Berlin. More than 29 years experience teaching in this university. He also productive scholar, especially in biology, molecular genetic, and biomediation, with the current index Scopus of 8. And currently, he also become the Vice Rector for Planning and Partnership of Universitas Sebelas Maret. So without further ado, Professor Sajidan, platform is yours.
Oh, thank you, Ms. Moderator.
Okay.
Honorable, my college Vice Rector for Academic Affairs, Prof. Ahmad Yunus, all the speakers, Professor Sen from Japan, Associate Professor Zulkifli from Malaysia, and also Associate Professor Cheper from Egypt, and also Professor Suranto from UNS. And Professor Suranto is head of a doctoral program in environmental science, graduate program Universitas Sebelas Maret, and also all participants. Assalamualaikum warahmatullahi wabarakatuh. Good morning and selamat pagi. First, I would like to thank the conference committee for inviting me to deliver a speech in this event. Here, I would like to share 2 things in this talk, which are the UNS experiences in contribution to the sustainable development. The first one is I want to talking is about water management to support green campus in UNS, in which the material is prepared by the UNS Green Campus teams, and UNS is committed to support the initiative of sustainable development goals, particularly with regard to the environmental issue. And therefore, we actively participate in the UE Green Metric, in which me plays 7th position in Indonesia, and also 96th position all around the world. Yeah. And the second part on my talk this morning is an experience on how UNS contributes in handling COVID-19. So, ladies and gentlemen, as we know, clean water is very important, in which the United Nations, which it is one of the Sustainable Development Goals. Water has several dimensions, which are space, quantity, and quality. Therefore, water utilization should be based on the balance and sustainability of surface water and groundwater. Yeah, this is an environmental clean in UNS, I think so. So, according to the law of the Republic Indonesia on water resource, it is mentioned that water resource management should be conducted by the government, community, and individuals. In line with this law, Universitas Sebelas Maret has committed to support the green initiative, including water management. Therefore, they create an environmentally friendly, campus. Yeah. Rector UNS issued a regulation on the guidelines for environmentally friendly campus management, namely Green Campus, for Universitas Sebelas Maret. Water management in Universitas Sebelas Maret, as a part of the Green Campus initiatives, consists of 4 aspects via efficiency of clean water usage. The second one is infiltration wells and bioporous construction. Third one is rainwater harvesting pool or lakes. This is Universitas Sebelas Maret lakes. And the fourth is wastewater recycling. The fourth aspect to lead to an output which is reduction of runoff and improvement of groundwater, which create a balance and water sustainability in UNS. Yeah. For the first initiative, which is efficiency of clean water usage, we did several activities, including water saving campaigns, via poster, as well as continuous socialization to all university members, including academic staff, supporting staff, and students. We have also done the gradual installation of water saving facilities and infrastructures. And for the second initiatives, which is infiltration wells and bioporous construction, this one. We have created bioporous over the period 2015 until now, with more than 500 holes scattered on campus. On the other hand, the construction of 117 infiltration wells is scattered in various places from the target of 300 infiltration wells. The two activities resulting in a significant increase of infiltration up to 48% following the infiltration wells contraction. For the third initiative is which is rainwater harvesting pool or lakes, UNS lakes. We have revitalized UNS lakes with an area around 1.206 hectare, and a volume of water around 7,959 meter cubic. UNS Lakes is created to maintain water balance on campus, and also our laboratory, educational tours, and also center for student learning. Yeah. This one is UNS Lakes. For the fourth initiative, which are wastewater recycling, recycle. This one, we have built a wastewater treatment plant, or IPAL, in Bahasa Indonesia IPAL, has been built in the campus of Universitas Maret, which basically dedicated to preventing groundwater pollution. It has a capacity of 1,290 cubic meter per day, and was inaugurated on March 2017 with the support of Minister of Public Work and Public Housing of Republic Indonesia. So, I think as the last slide to conclude my first talk, I will simply reiterate here that water management as an effort to support the green campus based on the regulation of Rector Universitas Maret on the guidelines for environmentally friendly campus management or green campus Universitas Maret. It has been done through two major agenda. First is the construction of pure infiltration hole, infiltration well, and UNS lakes to increase the quantity of groundwater. And the second one is the construction of wastewater treatment plant to prevent surface and groundwater pollution. So let me move to the second part of my talk with about how awareness contributes in handling COVID-19. As we have witnessed, the new coronavirus COVID-19 has been spreading all over the world. It has infected more than 50 million people, with the global death rate is around 2.5%. It is much massive than the previous disease outbreak, such as swine flu, Ebola, SARS, and MERS. This pandemic has by all means impacted most sectors in our lives, including higher education that most of us involved in. Yeah. So the first things that I would like to share is about the role of UNS Hospital in handling COVID-19. UNS Hospital is not only appointed as a referral hospital and laboratory for COVID-19, but also as a research center for COVID-19. There are several research projects related to COVID-19 funded by the Indonesian government, carried out in the research center in this hospital. This is UNS hospital condition in this time in COVID-19 outbreaks. And has also encouraged academic staff and students to create innovation to support the need of hospital in handling COVID-19, such as face shield and others. So, UNS also respond to COVID-19 term of helping students by providing subsidy of phone credit for students to support online teaching and learning process. Moreover, UNS collected the donation from academic and support staff and allocated them for those who deserve her, especially students who are still living around this UNS campus. Related to the academic and other activity core business, Universitas core business, UNS released several policies in responding the pandemic COVID-19, including work from home policies, BFH, work from home, and also the move the teaching and learning process to online system, course examination, thesis and dissertation defense can be done online. Student community service offered for thematic program on COVID-19, and also online graduation ceremony as well as online professorship inaugural ceremony. Moreover, students community service are also offered for thematic program on COVID-19 and extra. For example, the graduation ceremony videos has been viral, and watched by more than 1.5 million netizens. This one. For the non-academic policies, UNS released a policy on the budgeting with budget revision, namely GG, in bahasa Indonesia ganti and geser. This one is moving and replacing, refocusing on activities and handling COVID-19. To support research on COVID-19, the university offered call for proposal for academic staff for applied research on COVID-19. So, all these policies are basically done to mitigate the impact of COVID-19 and eventually to support the sustainable development goals. Thank you very much, for listening my talk. Hope this talk is beneficial for you. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Sajidan, for such interesting material on how university as a part of the environment try to manage and have to address the issue of COVID-19 and sustainable development. And I would like to invite all of the participants, if you may have a question regarding the Professor Sajidan presentation or to another speaker, I would like to invite you to drop the question in the chat box, and I will bring up the question to the speakers right after the last speaker delivered the material. So let's move to the second speaker of today's plenary session, Professor Zhenxiang Shen. So he is a professor at the School of Environmental Design, Kanazawa University, Japan. He is a member of the Engineering Academy of Japan since 2018, whose research interests include smart city construction, the policymaking support system for planning and design using GIS, VR, and information communication technology. He also editor-in-chief of the IRSCPD International Indexes Corpus and XE, and also some of the another reputable journal. So good morning, Professor Shen. So please, Prof, platform is yours. Would you please to unmute yourself, because apparently we cannot hear it.
Okay. I'm sorry, I muted my speakers.
No, it's okay,
thank you. Thank you very much for inviting me to give this talk and have this chance for communication with you. I think I have total 20 or 25 minutes for this talk. And firstly, I'd like to thank Dr. Iriwan to invite me to join this great event. And also thank for the members from the UNS and other keynote speakers. And thank you for the moderator, Ms. Dewanti, for moderating these sections. And my topic is simulation for urban planning and design. And today, recently, I have a chance to summarize all my research work in Japan. So, and also probably this topic also relate to the topic of the conference, the environmental and the sustainability conference. And this introduce myself. I think the Ms. Dewanti already introduced. So I originally from China, and now I'm working in University. And my research is in the field of an urban. And so my topic today can be divided to the three parts. And I'm doing research work in the field of urban simulation and virtual reality for support urban design. And all my research something probably you can imagine is about start from the human behavior and to the urban planning design and to the construction. So I will introduce my first part is agent-based model and simulations. And all this work is supported by the Japanese governments like the JSPS project. And my thinking for the urban simulation is like in Japan, we call the planning process as the planning framework. It starts from the economic demand allocation, and then turn to the land development, including housing and public facilities. And then the people will occupy the land parcel, and then they will have the transportation in the urban areas, and they will cause some environment issues. In local city in Japan, like Kanagawa cities, they start from the urban development, so we call it urban sprawl, and develop their business areas outside in the suburban areas. And then in the downtown, they will cause the urban decline issues. And then most population living in the downtown areas. And so there's a process like here, I show here is like start from urban sprawl and urban decline, and also downtown revitalization. This is quite important topic. And I will introduce some urban planning and simulation work today. And so first is a downtown regeneration policy. As you understood, I already introduced the development to develop the residence use in suburban areas. So the downtown then decline. And this is the urban planning area of Kanagawa cities. And in the left side, you can see there's the density of population. And in the right side, in the red part, is the downtown areas. And the blue part is the suburban areas. So there's a lot of residential development projects in that areas. And the government like to ask people to move from the blue part to the red part. So that's the urban residence promotion policies. They have some subsidy program for the people who like to move from the suburban area to the downtown. The government pays some. They will provide some subsidies for the people who move. And for this, as I introduced first, I considered our simulation from the period. So firstly, we consider the household relocation. So we consider the life cycle phases for each household who live in the downtown areas to simulate when he will, in what kind of condition he will move to the suburban to the downtown areas. So firstly, we define the where's the stage of the people who will consider relocation. In Japan, we find that the three household ages they will be possible to consider relocation. And first is the 20 years, and then get married in the 30 ages, and probably they have the children, a big family, they will move to a big house, and after the children became independent, and he became the aged person, probably have another chance for consider relocation. So in the fourth stage, it's possible for the household to use the urban residential promotion policy to move to suburban areas to downtown areas. So this is some kind of simulation. We use the virtual city of Kanazawa and simulate the urban policy and the urban condition of the urban policy inside the simulation system, and simulate the people, how the people move from downtown to move from the suburban areas to downtown. And for the people who will choose the downtown as their relocation areas, we make more than 10 years investigation for checking where's the impact factors for the relocation behaviors. So in the background of this slide, you can see there's lots of factors that is we collect from the questionnaire in Kanazawa cities. And this is just an example of our simulation work. And totally we will, how to say, we develop such a system. In the right side is the decision making, is for the decision making meetings. And in the right side, you can see there's a server side. Server side, you can imagine that the mayor will use the server side, and different department of the government will use the client side. This means the residential bureau or the transportation department or other organization in the cities. And the client can choose their own policies, and the mayor can check the comprehensive simulated result of all the supposed proposed policies by each department. And then mayor can make the final decision of the local city's policies. And we have done a lot of such kind of simulation works. Some work is published as in a journal. We have here we show two related journal. If you are interested, you can find this journal to read and answer more detail. So another one is about the disaster prevention and accommodation shelters. In Japan, there's a lot of that of disasters, including the earthquake. And as you can see here is the Kanazawa cities, which this map show the degrees of the earthquakes. And then we simulate which building will damages and which road will be blockaded in the when earthquake taking place. And we simulated the evacuation behavior and find the people who evacuate, how they will find the accommodation shelters in Kanazawa cities. So this is the GIS data we use for the simulations. You have the building data and all the road network data. And then we can simulate which building will be damaged during the earthquake and calculate, and then we can figure out how many people will leave the damaged house to the accommodation shelters. And when the people find the evacuation rule, actually they cannot use the road broken by the earthquake and by the debris of the buildings. So that is methodology, we simulated how the road will be located during the earthquake. And then finally we'll get such kind of results. You can see the start mark in yellow card is accommodation shelters, and the green, the point is mean the damaged buildings, and the people, the evacuee will escape from the buildings, and they choose the red road network as evacuation road to the start mark in accommodation shelters. And then we can summarize how many people will use the accommodation shelters. And because we have the data, the capacity of each accommodations, and then we can figure out which accommodation shelters is in the dangerous status. And the buildings mean they will cause the road blockaded in this map. And finally, we will understand which accommodation shelter is in the risk and which is safe. It means the number of evacuations will over the capacity of the accommodation shelters. So that's the result of the simulation. So there's also have 2 papers that published in the Nature Hazard Review and Disaster Situations. So if you are interested, you can find the 2 channels for more interesting, more information. And so this is the urban simulation work. Actually, we start from the consider the economy of demand allocations, and then we consider where to develop the housing and commercial and public facilities. And then we can simulate the interaction between the land use and transportation. And then we consider the environmental impact in the urbanization process. So that's the old consideration we are doing in the field of simulation work. And now let's start to the second part. The second part is about urban design. They also support many by Japanese governments and local cities governments. We are interested to simulate the urban planning regulation. We have developed a tool you can see here. This is a building, the possible the stories, and then we put all the parameters of road regulation, of the planning regulation in law, and we simulated how regulation will look like, and also we can put in the how the planning regulation will impact the building strength. And this is very useful for public transportation. And also, there is such kind of tool or invite the people to design the public part in their communities. So this kind of work we are use the virtual reality to support the planning urban design. They also have some design work to simulate the house. In this case, is the government like to build a pedestrian bridge, and we find a solution for the transportation traffic jam, and divide the people and the car in the different level. So this and we simulate the effect of the design of the additional bridge to find it's the problem traffic jam can be solved by this kind of design. So we simulated the amount of car, and also we simulated the number of the peoples in the crossroad, based on the real data. And also we have used the MR, mixed reality design tool to support the real site design. Like our camp, we like to know how we also design. So we also publish several a lot of publications of our urban design work using virtual realities. If you are interested, you can find a paper. And then I think it's my I introduced in the beginning. We start from the human behavior, and then we tend to the design and construction. So the final topic is about the smart city constructions. But in Japan, it's very important to reach the aim of the zero energy house that is issued by Japanese government. So for this kind of the research, we have 4 steps. One is to simulate the building form based on land regulation, and the design the solar panel, and find the solution of the energy consumption based on human behavior, and then we consider the energy management in the entire cities and the communities. But just like go through fastly, that's the main concept of the smart city construction in Japan. It's like this: the home energy management system. For each detached house, HAMs, we call it HAMs, can be installed in the detached houses, and then the people can use the generated solar electricity power by the solar panel. If they will, it's possible they can also save the generated electricity power to the urban facilities, and then keep the balance of the setting and the generation of the electricity powers. So to keep the balance, so we call it the zero energy house. But it's a little complicated, complicated concept. But it's for the Japanese government use HAMs for the zero energy house construction. And this work will simulate how much the building can generate the electricity powers in the entire years by each month. We simulate how many years can be used for the solar panel, and how much electricity power can be generated by the solar panels. And also we simulated the reflection from the surrounding buildings to consider which wall is also possible to install the solar panel. And this is some kind of simulation for consider the daylighting for energy saving. And this is some kind of simulation work we are doing. And we consider the opening sites, I mean the window, and that can use the daylighting. And then we can turn off the light if the daylighting from the outside is enough. And then this is possible for energy saving. And also we simulate all the house in the communities and try to keep the balance, how to keep the balance of the generation of the electricity powers by the solar panels, and between the they can offset the amount they can buy from the facilities in the cities, just like keep the balance of buying and selling of the energy electricity powers. Yeah, also we have several publications. If you are interested, you can find this publication for more information. Okay, it's all my research introduces. So my research is support the policy making and planning and design. And so we use the GIS technology and virtual reality technologies. So my topic, so that's me. The reason I designed my topic as urban simulation for urban planning and design. They also relate to the environmental issues. And I hope this topic is related to the conference. And finally, I'd like to introduce some publication, some journal and book series and we also organize one international, we call it international communities of space. We edited one journal, we cooperated with the Japanese government and published in this stage. Is international review for spatial planning and sustainable development. And also, we edited one series with Springer. The book series name is Spatial Planning and Sustainable Development. I hope you can, if you are interested to publish with us, you can submit a journal to the Journal International Review for Spatial Planning and Sustainable Development. And also, you are interested to publish a book with us, you can contact me and then send one proposal, and then we can consider publish the book in the book series, Spatial Planning and Sustainable Development. And thank you very much. I hope I did not occupy too much time. And now I'd like to close my speaking. Thank you very much.
Thank you very much, Professor Shen, for such an interesting question. And of course, it's still related to our theme today, how we talk about the sustainable development. And maybe in the discussion with the question and answer, we will discuss more on the how the urban planning in your area address the sustainable development related to COVID-19. And let's move to the third speaker for the plenary session, Associate Doctor, Professor Dr. Zulkifli Abdul Karim. He is an Associate Professor from Center for Sustainable and Inclusive Development, SID, Faculty of Economics and Management, National University of Malaysia. His expertise includes monetary economics, financial economics, applied econometrics, and banking, capital market, and also public policy. He holds his PhD in economics from University of Southampton, United Kingdom. And without further ado, good morning, Dr. Zulkifli.
Good morning, Ibu Dewanti.
Good morning, sir. And so I think it's quite interesting for us because with the previous speaker, we talked about another issue, and I think with your presentation, we will have a different perspective on how you address and respond to COVID-19 and sustainable development from your area. And for Dr. Zulkifli, I think it's okay for you to spend more than 25 minutes, and it's like 30 minutes is okay. So without further ado, please, the platform is yours.
Thank you, Ibu Dewanti, Cahya Ningsih, the moderator. My respected to Professor Ahmad Yunus, Vice Rector, Prof. Suranto, Chair of Environmental Science Studies, my fellow speakers, and to all audience. Right. Firstly, thank you very much for inviting me as a panel speakers for this first international conference. I think last time I already visited Universitas Sebelas Maret as a visiting professor. So during that time, face-to-face activity. Now we need to optimize online medium. Right. Okay, I think both speakers have discussed very interesting topic, which is focused on the micro aspect. So my focus today is try to share with all audience about the latest issue, COVID-19 and sustainable development. So how the national government respond. So my focus based on macroeconomic aspect because it's related with my expertise in macroeconomic. All right.
Yep.
My voice is clear, right?
I do apologize, Dr. Zulkifli. Would you please do like full screen your presentation because
Okay,
you are
sure.
not in the. Thank you.
Is it okay?
Okay, perfect, Doctor.
All right. Okay. Okay. So I will focus on how the Malaysian government respond during the COVID-19. So of course, my talk is on the macroeconomic aspect rather than microeconomic aspect. Right. So before that, let me start. I think everybody already familiar. The 17 goal, SDG by 2030. Right. So why I highlight this, because this is very important, because we are the researchers in any area. Mine focus on, of course, economic discipline. So my idea is to make sure we are, the researcher should contribute to any goal of the SDG, in particular for PhD researcher, or we are the pure academician. So mine, for example, my area mostly contribute to achieve SDG number 3, good health and well-being. Number 8, decent work and economic growth. And number 10, reduce inequality. This is my contribution to SDG. All right. Okay, so before that, let I start with the current status about COVID-19 in Malaysia. So maybe some of you are already familiar. The total cumulative case for Malaysia. So this data update, very update, yesterday figure. So now in Malaysia, we have total cumulative case for 2050. Right, so it's considers very high, the number of cases. So if you can see this figure here, so okay, now we're already in third wave of the COVID, right? Because last time, the second wave, we can see the figure during the second wave. I think everything is under control. So the Malaysian respond immediately. For example, we impose MCO. MCO we call the Movement Control Order. All right, so Movement Control Order. So we shut down everything. Okay, shut down economic activity, shut down everything lah. So economic activity cannot run. So so this implies that I think Malaysian government, we are the first country in Southeast Asia which is we impose total lockdown. Okay, on 18 March. So as a result, we managed to control this pandemic, right, during the second wave. And later on, when everything is actually not 100% back to normal, when government realized that we can manage or control the outbreak, so later on government restart our economy, and we move to the second phase, which we call conditional CMCO, Conditional Movement Control Order. So we restart our economy, but of course, subject to some standard operating procedure, some regulation, right? So that what we call start the economy. Okay, later on, government imposed the RMCO. R stand for recovery, recovery movement control order, right? And later on, what happened to Malaysia? So now we are facing the third wave. Okay, so the third wave. So that made the government and the society, of course, heading up how to manage the third wave. All right, so we cannot back to total lockdown, because total lockdown that will give very costly to the nation in terms of if we shut down the economy again. So what happened to the economic growth? Right. So the third wave government, we never shut down all economic activities, but that based on the what we call depend on the what we call scenario. For example, now we impose conditional moving control, the CMO, in a selected state. Not all state, selected state, which is the cases is in the red zone, right? For example, 50, I think more than 50, more than 50 cases that consider red zone. So government of Malaysia, now we lock down several states. Okay, for example, in Peninsular Malaysia, so far, only 3 states, not locked down, not full lockdown, right? The other state in Peninsula now under conditional movement control order. All right, so this is the way government responds. So if we can see this figure, under the third wave, now the average daily case in Malaysia has increased a lot, right? So average 3 digit, sometimes 4 digits, right? Yesterday, 800 cases, previously more than 100 cases per day. So very, I call very outward trending, right? I mean the new cases lah. All right. Okay, so now I want to share, so how the government respond to handle this pandemic. All right, so our policy, we introduce a 6R strategy. All right, so 6R strategy stand for, the first R is resolve, right? Resolve. All right, later on we go to resilient. So this one, government impose what I call stimulus package, right? So in Malaysia we call prihatin. So this is something like stimulus fiscal package, right? Okay. Later on, when we stop lockdown, so we restart our economy. So this is the third step. We restart economy. Later on, the recovery. Okay, so of course that need a lot of money, right, to restart and to recover our economy. All right, so I will later on I will show some figure. So how much Malaysian government has spent, right? Okay, so last Friday, so we moved to the fifth step, which is we revitalize our economy. So revitalize, so Malaysian government just presented our budget, budget 2030. So this is in our history, the very big money, or big allocation in budget 2030 compared to the previous budget. And now we are moving forward to the last step, right, which is to reform our economy. So reform, the government is expected to announce 12 Malaysian plan by January next year. So this is complete a 6R strategy, the way we handle the pandemic COVID. All right. Okay, so this is the detail about for each strategy. So we can see here the first strategy. So this one, Malaysian government announced package rancangan, which is stimulus package. It cost 20 billion on 27 February. Before you know that this is the period under Prime Minister Mahathir, right? Later on, Prime Mahathir stepped down. So now government changed to, now we call Perikatan Nasional. So under Perikatan Nasional, so the new government has announced another stimulus package. It costs under RM 330 billion ringgit. Right? Okay, so under we call it package prihatin. So under package prihatin, of course, we have various initiatives. For example, Bantuan Prihatin Nasional. We also introduced a wage subsidy to the affected businesses, automatic 6-month loan moratoriums. All right. We also introduced EPF Ilistari cash transfer, right, to the vulnerable people. Of course, we to support small medium enterprise, which is they are very affected during this pandemic. Okay, later on we move to Prihatin, another stimulus package. Prihatin, this one totally focused on PKS. I think Indonesia UKM, right? Usaha kecil menengah. Okay, so in Malaysia we call, right, usaha kecil menengah.
Yep.
Yeah, so in Malaysia we call PKS, or small medium enterprise. Okay, and later on government introduced Penjana. Okay, Penjana in 5th June 2020, which is cost 25 billion. So this one, government decided to extend the wage subsidy to the businesses, reskilling the fund, give one-off support to the vulnerable group, of course, financing the liquidity support to all parties. All right. And in 23rd September, so government announced another package, okay, which is we call Kita Prihatin. All right. Okay, so this is the economic impact to measure. So what we can see here in the first quarter of 2020, Malaysian economic growth has dropped 17.1%, because we are the first country in Southeast Asia to lock down everything, right? So that's why the second quarter, so our growth is negative 70.1%, which is higher than others neighboring countries around Southeast Asia. So what we can see here, the short-term macroeconomic indicators has dropped a bit. For example, the sale value of wholesale and retail trade, Malaysian Manufacturing Purchasing Manager Index, or PMI, Kuala Lumpur Composite Index, and Industrial Production Index has dropped when we shut down our economy on 18 March. So when we move to the second phase, which is conditional or CMO, conditional movement control order, which is we restart our economy. So we open the economic sectors, but of course subject to some regulation by the government. So now our economy is improving. All right. So of course, the projection by this year, of course, economic growth is still negative. Okay, so this is the effect of COVID on different industries. So for sure, we are very familiar about due to the COVID. So the hugely impacted industry, of course, airline and travel, and hospitality and leisure, right? Okay, I think the same scenario in all countries. So the statistic given by small medium bank, SME bank. So I think according to the figure during this period, 1 April to July, 4,552 small medium enterprise closing their business. A lot. Okay, so of course some sectors they are thriving sectors. We call thriving sector because they're not affected, right? In fact, their business is growing. Okay, so this is related to the glove industry. Of course, digital services like Zoom, Amazon, Netflix. So this another sector, they are become better off, but other sectors they become worse off during this pandemic. All right. So this one just this impact to the services sector. In general, services sector has dropped a lot during this pandemic. Okay, so in terms of Malaysian economic outlook, so this is what we are focusing for this year. So our economy is expected to contract 5.5%. So we project for the next year, our economy is expected to rebound in positive growth, which is 6.5 to 7.5 growth. So this is what projection given by Bank Negara, Malaysian Institute of Economic Research, and so actually this projection is consistent with what World Bank and IMF has predicted. Right. So now relating to SDG or the vision, we have vision 2030. The vision actually consistent with the SDG framework. So what we're going to target by 2030 and how we relate the impact of COVID, or in other words, the economic activity pasca or post COVID. So this is what Malaysian government plan. So we're going to share the prosperity vision by 2030. So in this case, of course, there is some structural problem or issue and the challenges to the Malaysian government after COVID-19, which is can group into 6 problems. For example, the issue of food security, limited employment opportunity, regional imbalances. So maybe that will affect to the SDG as well, lack of focus SDG, issue of the rising cost of living and inefficient affordable housing. So this is the main issue, right, after COVID-19. Okay, so now I want to share with you all, so how the Malaysian government mapping SDG with the budget. Okay, so this is the way Malaysian transform our economy. So we start with agriculture-based economy, So this is the early stage of our economic growth strategy. Later on, we move to manufacturing-based economy, like innovation, lab economy. All right. So now we are moving forward by 2020 and beyond. So we're going to introduce a 12 national plan by next year. So our new strategy based on humanization, economic age, which is key success factors is of course innovation, right? So the wise use of innovation, knowledge to be shared and work collaboratively, because now a lot of silo, the silo activities between industry. There is no collaboration between industries and universities, for example, and government. They work at silo. So now we try to remove all kinds of silo. Okay, of course, innovation is very important, right, to achieve the vision 2030. Okay, so for the post-COVID imperative for recovery plan, of course, so then we change the way we think and the way we strategize our new economic agenda. Okay, for example, previously we focus on material base, now we're moving forward to knowledge base, innovation, driven economy. Okay, previously we focus on output, now we focus on impact. What is the impact? Okay, of any research done by academia, for example, done by the research institute. Last time we focused on survival, now we focus on resilience. All right, so this is the new term, in order to make sure we can achieve what we target. All right. Okay, so the moving forward, the government mission, now we introduce the new term, which is we call MyST 1010 drivers. All right, so MyST meaning that science, technology, innovation, and economic. So this is short form, science, technology, innovation, economic, and 1010 drivers. All right, so we discussed later on. So in this case, we try to address the gap between socio-economic goal and research and development priorities. Actually, this is idea from Academy Science Malaysia. So last time the director has presented the idea by Academy Science Malaysia. So how the idea proposed by Academy Science Malaysia can be used by the government to moving forward. Right. So according to actually this is the new agenda, and this ST 1010 drivers already approved by Dewan Rakyat for House of Parliament. So by next year, the Malaysian government will formally announce our new strategy. Okay, so this is what we're going to do by next year. So we have two drivers here, which is science and technology drivers and Malaysian socio-economic drivers. So that's what we call 10-10 strategy, which is 10 socio-economic drivers and 10 science and technology drivers. So this is the metric, right? So the metric. Okay, for example, let's say, okay, how we can use the 5G and 6G drivers, okay, to accelerate national socio-economic drivers. For example, energy, business, financial service, culture, art and tourism, Medicare and healthcare, smart technology, smart city and transportation, water and food. So this is 4 socio-economic drivers, which is in order to accelerate, right, the socio-economic drivers. So that's need the coordination between science and technology drivers. Okay, so this is the metric. Okay, so in this case, each science and technology driver should be exploring core technology and possible application for the 10 Malaysian socio-economic drivers. So how to do that? Of course, that's need research, right? To do R&D. All right, research, development. Okay. Now we move forward. Not only focus on R&D. Now we focus on RDCI. All right. So this is the new term, right? RDCI, which is research, development, commercialization, and innovation. Okay. So we are moving forward. RDCI. All right. Okay. So this is some example how we use these 10 strategies. Okay, for example, let's say the first science technology drivers, 5G, 6G. So this can be used to accelerate socio-economic drivers. Of course, the issue is talent, right? So this is the big challenge to any countries, right? Because 5G, 6G, of course, this is very sophisticated technology. Of course, we need talent, right? So we don't need to invest a lot. Okay. Another question: the readiness of the industry toward 5G, 6G. All right. So this is an issue, lah. All right. Okay. The same thing. For example, how the science and technology drivers can be used for a certain industry. For example, let's say we're focusing on agriculture and forestry. Okay, so this is socio-economic drivers. So how these socio-economic drivers can optimize or utilize all kind of science technology drivers. Okay, so this is the way we sustain our economy, and of course, the target to achieve the sustainable development goals, right, by 2030. So now we need that we try to mapping our development agenda in which consistent with SDG goal by 2030. Okay, so this is the way we mapping the industry, right, or economic activity across entire Malaysia. So this one after of course they already conducted the pilot study. All right, so some state they will specializing, right, in industry or in activities, in economic activity, which is they already have advantage. Okay, for example, Penang, right? Penang, okay, this is Penang, northern part of Malaysia. Penang, we specializing in electric in E&E, electric and electronic industry. Okay, according to their competitive advantage or competitive. Sepang, we focus on airport, logistics. Okay, the part of Malaysia is Sabah and Sarawak. Okay, for example, Kuching, we specializing in chemical services. So this is the way we mapping 10 MICE strategy in every location. All right. So in this case, we believe that this strategy will make Malaysian become more dynamic, diversity, and futuristic. All right. Okay. So moving innovation-based economy. This one pre-COVID. So pre-COVID, of course, we already discussed RDCI issue in 11 Malaysian plan. So maybe under 11 Malaysian plans, still not what we call give impactful, okay, to the Malaysian businesses or Malaysian industry. So after COVID, so government need to replan or redesign our growth. So for example, now the idea is we no more to the return on investment, for example, right? So now we talk on what is the return on value. This is different, right? The same thing KPI. Okay, we are as a academician or researchers. Our KPI in papers, citation, postgraduate. Now we're moving forward. So now we try to change KPI to the KRI, key result indicator. So the impactful of our research to the stakeholders. So that's why my job as a deputy director at Pusat Idea, try to strategize how to strategize the multidisciplinary research. Okay, multidisciplinary research and transnational research. Okay, we cannot make research as a silo, right? So previously, most of the research is conducted by silo. Okay, only one faculty, for example, right? So of course, that's not solve the economic problem, right? So now we try to collaborate interdisciplinary, okay, to solve any issue. So this is not a sole, not sole research, okay? So now should come up with the impact to the nation, for example. So the impact to the nation should be The patent, for example, right? The number of patent, okay? So from the patent, it should be commercialized to the industry, right? So the impact to society, for example, can we become the game changer, for example, right? So now we introduce the concept of game changer, okay? So the game changer means that from our research, so how the research can change the industry, for example, can change the society. Okay, so now we try to come up with very impactful research, which is can come up with a game changer to the society. All right, so this one we can skip. Okay, so this is the current performance or achievement of Malaysia. So in terms of innovation, market competitiveness, knowledge and talent, so I think in average, it shows we are considered some at par compared to other countries. For example, innovation, right? According to Global Innovation Index, in 2019, so overall rank, we are 35 out of 129. But the problem is, when we rank in terms of product innovation, so this is very bad achievement. So when we rank by product innovation, so Malaysia we are number 130 out of 137. So this is not consistent with the Global Innovation Index. Right? Market, for example, so we are 34th largest exporter, right? But when we rank participation in global value chain, so we are number 53. So something is not consistent, okay? So that's why we're going to study. So why this happened? So is that wrong with the existing policy? So if something wrong with existing policy, we need to moving forward and try to identify. So what is the best strategies to moving forward? Okay, so all right. So this is an example of the way Malaysian government budget mapping with SDG. So this is example to Ministry of Energy. I just give one example because later on Malaysian government will be mapping the budget according to SDG. So they will mapping according to the ministry level. So each ministry, they should achieve any goal of the SDG. Okay, for example, let's say Ministry of Energy and Natural Resources and Ministry of Environment and Water. So we know that SDG we have 17 goals. So this ministry, they need to achieve the SDG 6, for example, right? The clean water and sanitation. Goal 7, affordable and clean energy. Goal 9, industry and innovation. Goal 11, sustainable cities and communities. So this is the allocation for the development expenditure approved by the cabinet to this ministry. So this is 2015, the budget allocation is 2.9 billion ringgit to achieve this SDG goal, and in 2019 has increased to 3.17 billion to achieve the SDG goal. All right. Okay, so budget 2021. So the Malaysian government mapping with SDG 2015. So by introduce the COVID-19 Act 2020. So in this case, according to this act, we allow the debt relief or rent relief to the vulnerable people. This act also allow the government debt statutory. The government debt per GDP has increased from 55% to 60% because previous statutory is the government debt per GDP cannot exceed 55%. So this is our statutory, mandatory. But to handle the COVID, the House of Parliament agreed, right, to increase our threshold to 60% starting by 2030. Okay, so we also established COVID-19 fund, which is now the cabinet already approved. The shilling for the fund is 65 billion ringgit to address all kind of COVID. Okay, we also introduced Sukuk Prihatin. Okay, so this is considered like to encourage more research, okay, or business that related to SDG. Malaysian government also established SDG Trust Fund, Malaysian SDG Trust Fund. We also allocate some budget for inter-parliamentary seat, which is focused on SDG as well. Okay, starting by next year, Malaysian government will introduce our sustainability bond, bond kelestarian, to finance environment and social initiative. And lastly, government will introduce a green technology financing scheme 3.0. I think GTFS 3.0. Okay, so this is the development in Malaysia, the way Malaysian government handle this pandemic, and how we try to sustain our long-term economic growth, right? And try to mapping with all the SDG goal. All right. Okay, so I think that's all for me. I hope my discussion can give some input, relevant input to the audience. Right. So this is based on the macroeconomic, the way Malaysian government handle this pandemic. So for sure, different countries have different strategies. Right. So we hope that our strategies is effective to make sure we can win this problem. For example, our economy can back to normal, can rebounded by next year, right? And this pandemic will end in a short time. So later on we can, we can do whatever we want as a normal, okay, as a normal. Okay, so I think that's all. So I return back to moderator. Okay, thank you very much.
Thank you very much, Dr. Zulkifli. So it's very interesting point of view on how Malaysia handled the COVID-19, and it's very interesting because we talk about the economic side and economic point of view, how a country addressing to solving and facing the crisis due to the outbreak of COVID-19. And to all of the participants, unfortunately, one of the invited speakers cannot join us till the end of the session. So Professor Shen, I think he cannot join us till the end of the session due to upcoming meeting in relation. So on behalf of the committee, I would like to say thank you very much for sharing insightful material on us, and unfortunately we cannot have a question and answer session with you by the end of the session. So once again, thank you very much, and let's proceed to another speakers. And I would like to remind all of the participants, if you have any question regarding any issue that already delivered, particularly in what delivered by the previous invited speaker, feel free to put your question in the chat box in the Zoom. So then I will bring up the question to you right after the last speaker delivered the material. And proceed to the next speaker, Associate Professor Dr. Ahmed Kaber. He got the PhD in Radar Remote and Sensing 3G GPR from the Tohoku University, Japan. He is a geologist specialized in application of remote sensing and hydrogeophysics of groundwater discovery in arid lands. And the current position is the faculty at the Geology Department, Faculty of Science, Port Said University, Egypt. So a very good morning, Dr. Kaber.
Thank you, Diwanti. Thank you.
It's quite early there, right?
It is, yeah. It is very early.
So thank you very much.
Thank you. It is my pleasure to be with you today, and thank you for the invitation. Yeah, it is very pleasure to deliver my research and share my research with you today. I will just share screen with you.
Yep, please.
Is it okay?
Oh, perfect, Dr. Kaber.
Okay, thank you. So since I graduated from Faculty of Engineering in Tohoku University in Japan, so and also since I am geologist, so we usually think about the human need. Usually the people need to live in safe, very far away from the hazard or mitigate the hazard. Secondly, they are searching and exploring for the resources, for hydrocarbon energy, for water, clean water, for food. So building materials, all these resources, minerals, all these resources also, it has a relationship. We explore it and get it from the earth. Third, also we are looking for the best location to store our wastes. So if it is solid waste or nuclear waste, whatever the waste, we will also try to find the good location for storing our waste. So as a geologist, we are helping to to measure the hazard, to mitigate it, and save life, and also helping in exploring the resources that we need. And third, also locating the best location for store our wastes. So we are using our technology to map all these interesting area. Today, I will just share with you only one theme, which is natural hazard that we are facing and how we are using the remote sensing satellite to detect and measure the natural hazard, and also proposing how we can deal with such natural hazard to save lives and mitigate the risk. Remote sensing is also fitting. So researching remote sensing means studying the earth without physical touching, without being in touch with the earth, and without being in touch with targets. So it is fitting with what we are doing today or nowadays with COVID-19. We are working and keeping distance always. So remote sensing, we are studying with keeping distance without touching. So it's somehow also fitting the protocols that we are used to do these days. So the title of my presentation today is Natural Disaster Management for Sustainable Development using radar remote sensing. We always looking for sustainable development, something sustained. As I mentioned before, we are daily interacting with our Earth's surface. We are daily interact with our Earth's surface. Using the new technologies to image the surface and the near surface, it is very important and applicable in many different fields. And one of them is the engineering field. So, for the natural hazard, we have many natural hazards. The earth is not stable yet. From time to time, we have volcanic eruptions, we have earthquakes, we have tsunamis, and all these risks, natural hazard. So we are plotting and archiving all these events and mapping the events. And finally, we have a final map about the predominant areas for natural hazard. And you have this world map. It is locating the red colors is very high for earthquake. And also we have a volcanic, we have tsunamis, cyclone, and all these natural hazards. And today I will share with you how we can use our remote sensing to also predict and detect and manage all such other The natural disasters can be classified in three categories. The natural, that already occurred from the earth, and natural human influence, and totally human influence. I will just give you some case studies how we can how remote sensing to detect the natural hazard and also something like human natural hazard. After the disaster, we are usually trying to relieve and rehabilitate with such kind of disaster and reconstruct and try to prevent the disaster. And also sometimes we are doing preparedness to deal with such kind of hazard. And this is called the disaster management cycle. In our remote sensing field, we are using the electromagnetic wave that already comes from the sun. We have the visible light and infrared and microwave. For the satellite research satellite, we are using the visible and infrared and microwave. But today I will share with you the microwave satellite, only the microwave satellite, the research that we are using for this research. The advantage of microwave satellites, the microwave is very powerful for tropical areas like Indonesia. Indonesia usually has clouds. So the radar satellite can penetrate the clouds and image the surface without any disturbance. So it is very good sensor to deal with the tropical areas. And this is the difference between the satellite image, the radar satellite image, the grayscale on the left, and the optical one. And we can see the clouds. So the clouds is very difficult. Makes the image is very difficult to deal with and extract information. So the radar is very clear and does not affected by the clouds. So we are using the radar. So the radar sensor, it's like a camera. So we can put this camera on satellite or in airplane, or we can put it in ground-based trail, or it can move on the top of the surface and image the ground surface, and it can be also used inside the borehole. So all of them are radar systems, radar sensor, radar camera. It's a transmitting radar wave and receiving the backscattered and the echo of this transmitting wave. This is very simply speaking about the radar sensor. And this is the satellite image, radar satellite image for the Cairo. And here is the Great Pyramids, the 3 pyramids. Usually it looks like a grayscale image. And this is another satellite, radar satellite image for Sydney. And we can see the building with very white, bright colors. Yeah, so when the satellite transmitting the radar wave propagate in the atmosphere and hitting the targets, and then scattered back to the satellite. So we can estimate the distance between the satellite and the target, especially for the building. And along different time series, we can measure the changes in the building. So if there is any movement in the building, so we can detect it in which direction and in which rate using the radar satellite. And we use this technology to estimate the land subsidence in the coastal area. So as I mentioned, if there is a change in the travel signals, we can measure the difference and convert it to distance or subsidence. We have ongoing research with collaboration with my colleague in ONDEB and OSM University in Samarang. And we tried to also estimate the land subsidence for Samarang. So for this project, we used 15 radar images. And these 15 radar images covering the period from July 2015 to May 2020. And our objective is to measuring the land subsidence of Samarang and the rate as a natural hazard and how we can propose the mitigation measures. So here is information that we already got after processing the 15 radar satellite image. This is the July 2015 on the top left, and then we reach May 2020 on the down right. So we can see that there is a high subsidence rate on the northwest coast of Samarang, and this is a mountainous area. Usually the mountainous area is a little bit stable. And this is the coastal area where there is a thick sedimentary cover and also flat, and there is an urban expansion on top of this area. And we can estimate accurately the subsidence rate. And this is the result that we already got from processing the radar satellite for Samarang. And of course, we try to do interpretation for such result. And we are expecting the causes of such subsidence is urban expansion. And in last few years, Samarang city has witnessed a very, very intensive urban expansion. And this is a satellite image for Samarang city in 1984. And if we just move to 2019, we can see the difference for urban expansion. So a lot of building on top of the coastal area, and this building make a compaction for the subsurface sediment. This is one causes for the land subsidence in Samarang, and I expect this is the main cause also. Plus some different causes may be structurally, like fault and groundwater extraction, and all these parameters also can causes land subsidence. Also, we try to do the same for my hometown, Port Said. Also, it is a coastal city located on the Mediterranean Sea, northeast of the Nile Delta. And also, we tried to, for Alexandria, also on the northwest of the Nile Delta, to measure the land subsidence. And also, here is a time series radar satellite image, and we can figure out the highly subsided rate areas, which is colored by red in this area. This is very, very helpful information to provide the decision makers to know where to build and where to carry out their project. And this is for Alexandria. Also, we have a different time series images, and we can also locate the highly subsided red color area along Alexandria city. This is of course for coastal city. Also from satellite, radar satellite, also we can expect another human hazard like oil spills. Usually the ships leaving some oil spills in the ocean, and make some environmental problems, very severe environmental problems. Using radar satellite, we can detect the track and the trajectory of the ship and the oil spills, and estimate the dimensions of such oil spills, and also proposing the proper mitigation measure and how to deal with such oil spills using the satellite. Another also problem is a glacial movement and ice melting. Also, we can detect it and measure the directions and rate and all this stuff using radar satellite images. Also, another problems like flooding, river flooding. Also, we can estimate the dimension of such flooding and imaging the scenarios and all this stuff using the radar satellite very easily, and providing the decision makers with important information, and also giving them the proposal how to deal with such kind of hazard. And here also another image for the flooding. Usually the international response is very, very also useful, and the international collaboration with different institutions, and especially the countries, those are already own the technology, new technology. Very, very useful to respond for the disaster and integrate all this information and response to the disaster. And there is already charter which is called the International Charter for Natural Disasters. This charter, they already have agreement, especially the countries those are own space agency like USA, Europe, and Japan. They already decided to make a charter and integrate the satellite images together and provide the countries those are suffering from natural hazard. And here is the members of the international charters, and they have a website. So here is the website. You can find it, the materials. You can just access this website and you can find the information about the hazard that we already faced, already updated information. And here you can see, like in November 6, in Mexico, Panama, typhoon in Philippines, Vietnam, flooding in Vietnam, with the date. So you have updated information about the hazard. And this website is very nice and very useful. We can move to another sensor, which is called the ground penetrating radar. It's very, very similar to the satellite. But the difference is this system or this camera or this sensor is moving on the top of the ground, not from space like satellite. So it is moving on top of the ground surface and sending the radar wave inside the ground and imaging what is inside. So we also using such kind of system to image the ground and helping the engineers to find out what they are looking for. So sometimes if there is a planning to build a city on the top of the ground, also they're asking us to image the ground to find out the stability of such kind of ground, making like a survey or soil survey. So sometimes we are figuring and imaging caves inside the ground. And this caves is very risky for the building. So we are imaging the cave, and this is my own data. This is the diffraction of the cave using radar, ground penetrating radar. And we can also estimate the dimension of the cave. And usually when we are surveying area, we are trying to make survey in the two directions, in the X direction and Y direction. This is a 3D model. We have a test area with the dimension 115 meter in X and 70 meter in Y direction. And we make a survey GBR profiles on both directions. And here we can see the moving profiles and with the diffraction of the caves along the Y direction. And this is on the other direction also. We can generate such kind of 2D profiles, GBR profiles, to detect the cavities under the ground to help the engineers when they are building the cities. And also we can generate the depth slices. We have, this is the ground surface, and we have the depth until 17 meter depth. So we can see the dimension and the shape of the caves. We can see here, these are the caves. And we can see the change, and this is also area has cave. And this is when we are moving down. Now we are in 3 meter depth, and the depth is getting down. So this information is very, very useful for the engineers, so they can inject concrete or make a scenarios how to deal with such kind of cavities. And of course, we can estimate the dimension of such caves. Also, another hazard in many areas along the world is the landmine. This is a human hazard, not natural hazard, human hazard, man-made. So during my PhD project in Japan, we did a test site in Miami, USA, and we just make our test site. We already buried some landmines dummies, and we did a GBR survey for the area. We did this survey without burying the landmines, and then after burying the landmines, we can see exactly the position of the landmines here, and by subtract this from this, we can obtain such kind of residual, and we can exactly locate the location of the landmines, and this is the zoom in for landmines. So also this technology is very, very useful and has many, many applications, and very, very useful for imaging and detecting the hazard. So my conclusion is imaging the surface and near surface of our Earth where we live and interact using the radar technology is very useful to detect the different natural hazards and helps a lot to propose the proper mitigation measures for sustainable development. And by this, I ended my presentation, and you are welcome for any questions. Thank you.
Thank you very much for Dr. Gaber. I think it's very interesting because you share the point of view of your expertise on how natural disaster management for sustainable development using radar remote sensors can be done to respond to, particularly to our theme today, COVID-19 and sustainable development. I'm pretty sure a lot of questions will be addressed to you. So let's move to the last but not least speaker, Professor Suranto. He is a full professor from Biology Department, Faculty of Mathematics and Natural Sciences, Universitas Sebelas Maret. And he is the head of doctoral program in Environmental Science School of Postgraduate Program, Universitas Sebelas Maret. His expertise include molecular biology, plant virology, and biotechnology. Professor Suranto holds his Master in Science in Biology, Plant Protein from University of Tasmania, Hobart, Australia, and PhD in Botany or Molecular Plant Virology from La Trobe University, Melbourne, Australia. He is also a member of the Association of Indonesian Biodiversity Scientists since 2010. So good morning, Professor. It's such a long week
good morning.
until your turn.
Go to afternoon now.
Oh,
yeah.
So
okay.
it's moved to the noon. So please, Professor, platform is yours.
Okay, thank you very much, Ms. Devanti, our moderator today. Well, I would like to thank all friends of mine who has already presented his paper. This actually is very nice for my student actually. Well, today I am going to talk to you about the biotechnology and its role in overcoming the world food crisis. This is environmental consideration because you know that at the moment is COVID-19 has made several, especially for underdeveloping country, a number of people suffering needed to eat food. So that's why we try to pick up this title. So in my title, we are going to talk about what is biotechnology in overcoming the world food crisis, and I'm going to talk to you about a little bit about the viruses. But this is my field of study, plant viruses. But actually, when someone working with the viruses actually could be using the sample of human being, animal, or even the plant. Next slide, please. Talking about the science and technology, we have 4 subjects that really needed to be studied intensively: physics, chemistry, biology, math. So when I was become junior staff member in our university, I got a scholarship from Australian government that he said, I will give you the scholarship, but just for subjects, for this basic science, because they believe if our basic science develop very well, then our technology will develop very well as also. So that's why the reason why the government of Australia giving the scholarship it was to Indonesian scholarship or Indonesian young junior member in the university. Next slide. So, dealing with the basic science, namely physics, chemistry, biology, mathematics, then we can see, yeah, the interrelationship between the biology with another subject. We can make the agriculture and then medicine, biotechnology, and people using the statistic, how to calculate, yeah, the height of plant and the diameter of the stem, etc. And also we use computer science, geography, biochemistry, and the interesting one is the biophysics one. We are talking about the biological clock. Yeah, people trying to wake up in the morning and sleep during the night, and the pattern will be studied intensively if someone working with the biophysics. So, good relationship between the above subject, yeah, basic chemistry, biology, mathematics, will determine the quality of human being and environmental condition, yeah, in the world. So we should make sure that I am, as a biologist, I should know a bit more about chemistry, yeah, probably physics as well. So that's why the good relationship between the above subject will determine the quality of human being and environmental condition. Next. Yeah. So here we are. This is the history of biotechnology. Yeah, we have to thank Karl Ergi, the first people that used the word of biotechnology when he is going to give the cattle using sugar beet. And during 1940s, yeah, we knew that antibiotics such as penicillin have been produced in huge production. Yeah, and then in 1950s, 60s, we do understand what's the era of single-stranded DNA and also double-stranded DNA. And during 1970s, we call the gene technology. We can have insulin production, yeah, usually used by man and animal. We can produce by introducing the small organism we call E. coli. Yeah, then we can use, yeah, by using this bacteria, then we can use, we can have a lot of insulin production, not using the man on animal. In 1980s, we could sequence our DNA, yeah, automatically. And in this era, the recombinant DNA technology have made quite good result of this experiment by introducing the vaccine. So at the moment, people in the world also try to get a good vaccine for COVID-19 at the moment. Next. So this is the era 80s and 90s. People working with sequencing DNA automatically. Yeah. So before that, well, in 1990s, yeah, I used not only the automatically, but also the manual one, how to get the sequence of the DNA. And during the time, recombinant technology, yeah, to produce the vaccine also has been introduced. Yeah. During that time, I'm working with my pharmacist. Yeah. So this is the method of PCR, yeah, polymerase chain reaction, how to amplify the DNA. And we can know at the moment that cloning for the animal and transgenic plants has been introduced so widely, and we could have the benefit of this technology to overcome the problem in the world now is starvation. The question is, could the technological approach solve the above food crisis? Here we are, yeah, the next slide. Yeah. We can have a look, what's the concern of the world crisis now? Next slide, please. Yes. Yeah, we can see that the world problem, at least we can see this is the first problem, is the total number of population in the world. Yeah. First of all, the growth population in the world is very high, especially in the developing countries or in underdeveloping countries. Yeah. The second one is decreasing the good quality of soil, especially in developing countries. We can see many areas have been changing to be probably supermarket, or probably can be build up a house there. Yeah, and another one, yeah, that's also become the world problem is diseases. Yeah, diseases not only in plant, especially the virus one. So at the moment we also got the problem with COVID-19. So this is the viruses as well. So how to solve this problem? We try to introduce the biotechnological approach. We try to overcome this problem. So this is the solution we try to introduce here. Good biotechnology approach solve the above problem. Next slide. So we try to have a look whether using this biotechnological approach we can consume more food by genetically engineered plant that we produce in our laboratory, and then we try to plan for field trial. Okay. So this is the next slide we can see. This is the picture. The picture, the increasing number of people, yeah, since 1950s. Yeah, during 1950s, there is no people in the world, yeah, no starvation there. Yeah, Germany, France, Italy, England, Japan, yeah, and have look. In 40 years' time, the total number, especially for the developed countries, is so small, the percentage. Yeah, from 68 to 80, and then from 90 to 2020, only 1 million people during 40 years, yeah, especially for the developed country such as Germany, France, Italy, England. But on the other hand, we can see China, India, and Indonesia, you know, the total number of people increasingly so rapidly. So if we compare with this total number of people, yeah, and we compare with the producing food, we can see on the next table, please. Yeah. So the P1 is the production of cereal crops, yeah, and the C1 is the consumption. So we can see in 1950s there is no people, yeah, starvation there, yeah, including Egypt, yeah, Mr. Professor Ahmad Gober, yeah, you got 1 million tons, yeah, surplus there. But we are no worry, especially in developing countries. Yeah, during 1990s, yeah, including in our country, in the country still way more. Yeah, we still got 3 million tons surplus there, but such as Pakistan, and also if we are not concerning in producing the food, yeah, in 2030 will be many people starvation maybe. So this is the important why we try to introduce the biotechnological new one, yeah, the molecular biotechnology that we are going to overcome this problem in the near future. Next slide, please. So this is comparison of the rice production within 7 Asian countries. As we can see, Indonesia still under Vietnam, totaling the production a ton per hectare. Yeah, as we know that in a couple of decades ago, many people Vietnamese went to Indonesia, asked how to plant the rice correctly. And then it was Mr. Suharto said, well, okay, you can help people from Vietnam to grow better rice there. But at the moment, with Vietnam's people, yeah, becoming a good production of rice. And a couple of years ago, Indonesia also imported rice from Vietnam. So this is the picture, yeah, that actually we have to improve the total number of tons per hectare in our field of rice. Next slide, please. Yeah. Why this is so small? Yeah. Next slide, please. Yeah. Here we are. As we already known that during 2018 and 2019, Indonesian government has special action to plant rice, maize, and soybean, yeah, by improving the area's total number used in our area in Indonesia. But as we can see, the total areas, yeah, is 11.28 during 2018, and 1 year later we can see reducing the total areas for planting is better, yeah, become evident. So from 11.28 become 10.68, and rice production for the first one is a total, is still raw material, still with seed there. We have 59.18, yeah, tons per hectare, and during 2019 it become only 51.83. So in average, the rice production in our country only 5.2 tons per hectare, and then last year reducing again, yeah, become 4.8 tons per hectare. Next slide, please. So actually, reducing the good quality of rice in the world also occur everywhere. During 1950s, we can see every people in the world try to use land for planting the cereal crops, nearly 0.23 hectare per person. But during, before 2010, only 0.10 hectare per person, and in 2030 will be less than 0.1 hectare per person, yeah, for planting the cereal crop. This is a picture that actually we have to give more attention how to prepare the food in the near future. Next slide, please. So, why do we need food crops that are resistant to pests or disease, or we call transgenic plant? United States of America has calculated the loss by pest and diseases reach more than probably 37% of the total production. So if we try to make this in money in Indonesia, especially, this become 61 billion, yeah, per year. So it's huge money. Probably a number of departments, the budget is less than that total money. Next slide, please. Yeah. So this is the simple or the procedure how to make the transgenic plant. Yeah. After we have to isolate the gene that probably very useful for human being, then we try to clone. After that, we can use for this factor to put this gene. Yeah. We are called cloning one. After that, we can do to introduce this gene to the plant by a particle bombardment, or we can use using the agrobacterium tumultuation, using the certain bacteria to carry this gene and then introduce to the cell of the plant. So we expect that from this experiment, we have one plant that resistant to certain viruses or certain diseases of the plant. Next slide, please. So this is the picture of area biotech crops during 1996 until about 2010 in million hectare. Next slide, please. Yes. This is 25 year. Egypt also produced maize. When I was there, many KFC, Kentucky Fried Chicken in Egypt, not using the potatoes to eat the chicken. Yeah, they try to introduce the maize. This very sweet one. I still remember the day when I was there in 2010 or 9. Yeah. So this one, you know, many people try to produce maize. And I think, look, yeah, the best quality of player, football player in the world, usually eating maize, not rice. So Muhammad Salah, you know, the Liverpool one, this is from Egypt also, from your country. So this is 25 big countries that produce botanic crops in the world. So we also probably ask, what for we have to make transgenic plant of papaya? You know, papaya in Indonesia is very popular and very cheap one. Yes, this is to be honest, that this plant very easily to be grown in tropical countries. But when I was in Australia, and probably more than 7 years there, and there is no papaya there. Yeah, papaya is so expensive, so that's why people in United States try to grow or to plant papaya. Yeah. Next slide, please. So we can see this is in the map. Yeah, yeah. Professor Gaber is proud because the name of Egypt Day, yeah, but not for Indonesian government day. But the problem is in probably during 2001, there's a big demonstration in our country, especially in two districts in Bulukumba and Bantaeng. Yeah, they are refusing transgenic plant because many local people demonstrated because they said, well, the local cotton could be used because many people try to use the production of GMO from Monsanto, United States. When I was accompany my Minister of Environment, Mr. Nabil Makarim, and also Mr. Manuel Casifonde, and actually this experiment only field trial, not really planting Indonesia, and our people in Indonesia is very dependent to the seed or to the cotton seed to be planting before the season should be done in the following year. Next slide, please. So we can have a look. This is the big 8 countries from 25 countries that we have already looked at there. United States, of course, nearly half, 48%, yeah, planting this botanical crops, yeah, nearly 64 million hectares, and then followed by Brazil, Argentina, India, Canada, China, Paraguay, and South Africa. Yeah. So this is the big countries that produce a lot of plant that useful for human being. Okay, next slide, please. So this is the progress of biotechnology in our country. Yeah, if we are working with the development of GMO, genetically modified organism, then we need people from molecular biology, of course, and also biotech crops. We are working with tissue culture, of course, and some of experts should be coming from soil microbiology, and genetic engineering should be done in order to make sure that our GMO is not muted during our process. When I was working with my gene, I'm working with, later on we'll have a look like what look like the virus that I'm working with. Next slide, please. This is our position. This is Indonesian government position concerning with the global concern, a genetically modified organism. Yes, yeah. We do believe that GMO should be useful, yeah, for human health, but not harming, yeah, not destroying our environment. This is our belief. Next slide, please. And Indonesian government have made a good position to accept this GAP, genetically genetic engineering plan or better crop with precautionary approach. We have to make risk analysis to make sure that what we are working with is good for environment. Yeah, because we are dealing with environment. Next slide, please. So when we are working with this approach, we need regulation, of course, regulatory bodies, yeah, the institution. So the biosafety containment, yeah, I'm talking with this one because when I was in Australia, I have to get the permission from the GMAC. Yeah, GMAC is Genetic Manipulation Advisory Committee in Canberra, yeah, when I was working in Melbourne. So this is, we need this permission because if not, it's very dangerous. Because the recombinant virus that I made, yeah, needs certain glass house, yeah, before we are trying to introduce to inoculate or to make infection to the host, we should have the biosafety containment, this one. Next slide, please. Yeah.
I do apologize, Professor Surento. Would you please to make it shorten because your time is like a 4 minute left.
Yeah, this is just little picture that we can see comparison between the infected and the healthy one, the small one, cherries that you like usually. Yeah, this is the infected by virus. Yeah, and also the pumpkin one. Yeah, this is the tissue deformation because affected by the virus, and also the flower breaking. Next slide. Yes. Okay, we can have the particle. This is the number of particle virus that we can see. Yeah, that's nice. Okay, the rigid rod, flexuous rod, spherical, vacilliform, and germinate. Next slide. Yep. Yes, we can run. This is the structure, the basic structure of the viruses. Yeah, as we can see, this is one probably just like the COVID one. Yeah, this is the filament. Yeah, this is the tobacco mosaic virus. Yeah. Next slide. Yep. Okay, this is the factor that usually carry the viruses. Yeah, we can have a look. Beetle, aphids, mites, yeah, lephopper, etc. Next slide. Yep. Okay, we just go a bit. And this is the example of a tomato infected by the viruses. As we can see here, this is the symptom causing the poor quality of tomato, and this of course will affect the market values. Next slide. Yep. Okay, this is the product that usually you eat. Yeah. This is the product of modern biotechnology. This is the golden rice produced by Japanese. Yeah, but even they have already produced this rice, but they don't want to eat it. Yeah. This is your rice, the white one. This Indonesian rice. Yeah, and this is the corn. Yeah, just we try to engineer the tobacco. When this insect eats the tobacco, then will kill because they produce a toxic substance. Next slide. Yep. So this is the golden rice. Yeah, there's a lot of vitamin there. Okay, the vitamin A especially. Next, we can see, just put very quickly because we just saw this is the product of botanical crop. Yeah, just push. Yeah, quick. Yeah, biotech this corn, and then okay, push quickly. Yep. Okay, next. Yeah, and then we can see this is the meats or facts. This is people. Yeah, producing a lot of production. Next. Yep. Yeah. The truth about the biotech crops. Yeah. Now, this is the important one. We can see in the scope of environmental problem when people doing which. So when I'm working with the transgenic plant, so the uncertainty of impact is so move to the right one. And then people working with the depletion ozone layer, when I was in Australia, people concerning with the depletion ozone layer there. Yeah. So this is the arrow, this one. People working with the transgenic plant, usually the uncertain impact will come up. Okay, go ahead. Yeah, next slide. Here we are. How about if we are dealing with the recombinant virus? Okay, next slide. Yeah. So what's really in the, okay, this is the properties of the virus. I will show you the virus that attack the plant. Okay, let's go ahead. Yeah, because the time, yeah, run out. Yeah. This is the molecular weight, this is the pattern, and this is the symptom. So have a look. This one, the symptom that virus attack the maize. Yeah, the nice one, the bright one, but this is 6. Okay, next slide. When try to isolate this one, next slide, please. Yeah, try to isolate this plant. Then we have to look. This is the structure, the genome structure. Yeah, the P1 protein, the helper component, P3, and then solution in the body, in the small one, and this is the one, the very important one, this code protein gene, and they usually used by people to protect, yeah, to produce the transgenic one. Next slide, please. Yep. Yeah. This one, the function of this gene is protection from genomic RNA for virus movement and also the API transmission. Next slide, please. So when we are working with the gene, we are trying to sequence the DNA. Yeah? This is the whole lot of the DNA. It puts a bit more. Yeah, this is the N-terminal region. This is the core region, and this is the C-tail. Okay, next slide. Yep, just quickly. Yep, we can and we try to show you what actually the mutation occur in these viruses. This is my viruses, the new one, the Johnson grass mosaic virus, the CRIS one, is muted from the wild type one. But the other 2 viruses from the United States is the similar amino acid there. This is a number of amino acid occur muted from the wild type one. Next slide. Yeah. So here, how to construct the recombinant virus, GGMP. This is the new virus one. We try to pick up the code protein gene, and we try to introduce the new strain, put there, yeah, with this step, and then we can have the recombinant virus there, yeah. So have been replaced the wild type code protein gene and replaced by the new one, the CRIS infecting strain. This is we call the recombinant viruses. Okay, next slide. So here we are, the following construct of in vitro transcript. This is the wild type one. This is the cDNA, and this is the recombinant. Then this is the total new viruses, because the code protein, the wild type, have been picked up, and we introduce the new one. We have the first mutant. But when we introduce the new viruses, some part of DNA from the NIB still there. So we make the mutant too. We thought the NIB DNA. So we have 2 mutants. People working with this one should obey, yeah, the rule of the government by having the permission we call the GMAC one, Genetic Manipulation Advisory Committee. So we have to use the special confinement to work with this new virus atau recombinant virus, because yes, this one is still available in the world, but this 2 mutant is not available in the world. So we have to be careful working with this one. Next slide, please. So here we are. We have to use this one. I have been stopped at WAS. Yeah, 1 year I couldn't work because this glasshouse hasn't available yet. Yeah, so after I make a report to the department, and this is PC2 glasshouse. We prepare all our material here, including soil should be purified. Yeah, this is our PC2 glasshouse that we are going to introduce to make infection to the host by introducing the new viruses, the recombinant viruses. Next slide, please. Yeah. Yep, this is the picture that we taken from the front of this building, and of course, this should be obeyed when we are trying to make sure that environment should be safe by our experiment. Next slide. Okay, thank you very much. This is my head department. Yeah, when I was there, this is Professor Paris. When I was back to Australia in 2010, we are going to make a double degree in there. Next slide here. We make a meeting with certain person to make sure that we are going to introduce the double degree with him. Again, next slide. And this is the last one. Okay. This is time for you to have meeting. Okay, and the last one is a time for you having lunch. Thank you very much.
Thank you very much, Professor Surento. I think we directly move to the question and answer session. We have a lot of questions, so without further ado, let's move to the first question. It's addressed to Professor Surento. So it's coming from Fidele Inagura. As mentioned in the as mentioned in the previous presentation, it will be there will be a food crisis after the COVID-19. What are your suggestions or your contribution to the discipline of biotechnology to get the solution?
Yeah. Okay. Thank you, Fidele. Well, from now on, if we are not giving the good attention, big attention to our nation, especially, well, introducing a new product of biotechnology, transgenic, is good, but we have to make sure that the gene that we are working with is not dangerous. So the code protein gene is a good one. Yeah, friend of mine, when I was in Melbourne, I'm working with one guys from Korea and one guys from IPB. We are working with this gene of the code protein. Yeah. So when I got a special project from the government, especially my government, I'm working with the rice tangro spherical virus, usually attack the rice in a number of countries. Yeah. By introducing this gene, we should expect that this rice should be free from attacking the virus. So if we are not starting from now on, we always dependent from the developed countries. So your country, probably you can work with us, yeah, trying to develop. Because friend of mine from Ethiopia, yeah, I got student from Ethiopia. When I give the lecture, he was very interested to introduce the new technology, how to classify the plant using the protein, using the DNA. Then when he back, he got the master degree, and then he went back to Ethiopia. He said to his boss, and then the vice rector for academic affair and also the director for animal science, he went to my home university, and I also have been invited by him to go to Ethiopia. So this is a good chance for us to build up the biotechnology for our country. So welcome, Fedele. If you are going to study in my department, it's welcome. Please try to make sure that you are probably interested with new biotechnology, yeah, introducing probably how to make sure the environment should be better, yeah, when we try to introduce this technology. So dealing with the food, of course, we should make sure that agreement between us will be benefit both our country. Yeah, we are welcome to work. When I was in Australia in 1994 until 1998, yeah, people working with these viruses, yeah, the Australian government has stopped it. And my boss, yeah, Professor Sukla, actually this is the expert of the virus, but the government stopped it. Sukla, you stop working with the plant viruses. So at the moment he is working with the plant or human viruses.
Okay.
So that's very useful. So working with the food crisis, our good relationship between developing countries and underdeveloping countries should be make better and better to make sure that our government will have a benefit from this technology. That's demanding.
Thank you very much, Prof. Surento. And the next question addressed to Dr. Gaber. Indonesia, which is geographically located in the Ring of Fire, so that is a high potential to have a natural disaster. Is the use of radar imagery more effective than other satellite imagery, and why? Please, Dr. Gaber. Would you please to unmute yourself first? Thank you.
You're welcome. Yes, the radar imagery is very, very effective and powerful than the other satellites. As I mentioned in my presentation, there are three different informations that we can extract from space. The optical one, and thermal, and radar. Optical and thermal, they have a limited application. And radar also, as I mentioned, is very, very good because it can penetrate clouds that already covered the tropical regions most of the year. And also, radar is active satellite is working 24 hours. The other satellite working only daytime. So monitoring the Earth 24 hours is also very, very useful. Plus, the radar satellite is transmitting its own signals, and we can estimate the distance between the satellite and the ground surface. So by changing the travel distance, we can estimate easily the changes of the ground surface, the deformation of the ground surface. So yeah, from application point of view, the radar satellite is more powerful for the unstable and detecting the deformation of the Earth's surface. Yeah.
Okay, thank you very much, Dr. Gaber. The next question is also addresses to you. Is it possible the radar imagery detect or imaging or the heat thermal condition due to climate change on surface or near surface area?
Can detect what? The climate change?
Yeah, is it possible the radar imagery detect or imaging the condition due to climate change?
Yes, also most of the weather and forecast are using the radar satellite, by the way. Yeah, for estimate the precipitation, wind speed, the wave height of the oceans, wave directions, and all these weather conditions can be recorded, yeah. And using different time series satellite. But yeah, I have to say also the radar satellite are relatively new than the other satellites. So by archiving the data and information, of course, we can statistically expecting the trend of the weather. So yeah, by using the old information, old and archiving information, we can make some expectation for the change. Yeah.
Thank you very much, Dr. Gaber. And before I move to another question, this question will be addressed for Dr. Zulkifli. Are you there, Dr. Zulkifli?
Yes, yes, I'm here.
Okay. The question is about, you already explained about the Malaysia response to the COVID-19. So the question is coming from Sigit Subandiono. What are your suggestions based on your experience at macroeconomic situation in Malaysia that can be implemented in Indonesia facing the COVID-19 pandemic? Thank you very much. And before Dr. Zulkifli answer the question, I would like also to remind all of the participants that the committee already dropped the attendance list link. So please fill the attendance list so you can get the certificate later. Thank you very much. So please, Dr. Zulkifli.
Okay, thank you for the question. I think this is very interesting and very general question, because we know that for sure Indonesian, of course, you have your different way to respond for this pandemic. For sure, in Malaysian experience, our strategies is both expansionary policies. As I mentioned before, we implemented expansionary fiscal policy, and of course, monetary policy. So both they are expansionary. Right. So maybe for Indonesian experience, to suggest or recommend to the Indonesian government, maybe that's not my expertise because it depends on your policy, right? Okay, for sure, the Central Bank of Indonesia, for example, or Ministry of Finance Indonesia, so you already established the good policy, for example, right? So for Malaysian situation, so as I mentioned before, we are the first country lock down our economy. So in fact, is the second quarter. So we are the what I call among the Asian countries. So we are the worst in terms of economic growth. So because the rationale is why we start lock down the economy, because we want to recover, and so we can re-strategize our economy earlier, right? So that's the reason why we shut down earlier compared another Asian countries. All right. So my suggestion to Indonesia, maybe because we know that Indonesia has a lot of many islands. So each island there is a uniqueness. Of course, there is what we call the competitive advantage, right? Okay, across island. Of course, in terms of policy coordination between fiscal and monetary, they should be coordinate each others. Because if the macroeconomic policy work as a silo, so we cannot achieve what we want to target. For example, our target to achieve SDG by 2030, for example, right? So that's the coordination policy between micro level, okay, as well. So in terms of policymakers, so should moving forward by considering forward-looking strategies. For example, what we want to achieve by 2030, for example, right? Okay, so by coordinate each policies, I think, of course, there is another issue. For example, okay, first, both policy can be implemented. Of course, that will incur cost, right? Cost to the government. Okay, so for example, if you want to achieve SDG by 2030, how much money should we invest? Okay, to achieve SDG 2030, right? There's another question. Second question is how we can speed up this process. Okay, because sometimes policy implemented maybe a lot of leakage in the economy, for example, right? Okay, so missing money, for example, we don't know. Okay, so this is another issue. We, as policymakers, they need to ensure that every dollars they invest in the economy, okay, that should what you call can go to the each grassroots level, for example. Okay, there is no leakage in the economy. Okay, so another thing to consider is how efficient is the policy. There's another issue in macroeconomics formulation. Okay, how efficient is how fast is this policy can be translated to the all the grassroots or economic agent, for example. Okay, for example, the main agent is businesses, people. Okay, so this policy, for example, fiscal policy, right? Fiscal monetary policy. So how these two policies, okay, can be leveraged by these parties for their, for example, businesses, of course, for their future investment, for example, for consumers. So can we survive in future, given all kind of macroeconomic shock? Because now this is shock. Okay, COVID-19 is totally unique because we don't have experienced before 3 shocks simultaneously in our economy, right? So that's why we call that 3 shock, which is demand shock, supply shock, and financial market shock. So this is the unique COVID-19. Of course, when this is very unique crisis, so that need very unique policy, okay, to solve this problem. This is my general response. But for sure, Indonesian government, you have your own style, or your own policy, okay, to make sure Indonesian government can stabilize the economy and this pandemic will end sooner. This is my general response. Okay, thank you.
Oh, thank you, Dr. Zulkifli. Another question is also addresses to you. There's a question from Saiful. The question is about, you already mentioned a very comprehensive plan of Malaysia regarding addressing the crisis. For example, you're mentioning about my STIA 1010 drivers. It's very comprehensive. And the question from Saiful is about, does the Malaysian government include and like guide also the researcher to formulate this very comprehensive material? Doctor, please.
Okay, yes, thank you. Okay, in terms of the number of researchers, actually I have the slide. I'm not sure because the problem is in any countries is the number of researchers per population, right? For example, in advanced countries, the number of researcher population is higher than if you compare to developed countries, for example, right? So this is our challenge. The same thing in Southeast Asia or any developed countries. So what we're going to do is we try to increase the number of researcher. Okay, so researcher maybe can come from research university or maybe from the research institution. Okay, so this is what we're going to do. Try to increase the number of researchers. Okay, at the same time, any research should be impactful to the nation. Okay, because maybe the last strategies we make some mistakes. For example, we just focus on up to research and development. In terms of commercialization, this is another challenge because not many research conducted by university can go for the commercialization, right? So an average formulation, I think formulation, the latest data, we only can go around 3%, which is research conducted by university can go for the commercialization. Only 2%, very small amount. Okay, some agencies claim that their research can go for commercialization around 5%. Okay, so we take this issue very seriously. So the next agenda, so our strategy is try to make sure there is a collaboration between all parties in the economy. Of course, government will provide special allocation or special fund to any research institution to come up with their new R&D, right? To come up with new technology, for example. So of course, the main challenge is talent, as I mentioned before, the talent.
Okay. Okay.
All right. So that's why we're going to strategize how to make sure we have enough talent, okay, for our future development.
Thank you very much, Dr. Zulkifli, and also all of the invited speakers for sharing a very nice presentation. And we are about the end of the plenary session, and I would like to invite all of the participants and also all of the invited speakers to turn on the camera because we will have a photo session with all of the participants and also the presenter. So in count of 3, we will do 3 times. 1, 2, 3. Okay, thank you very much to all of the participants and to all of the speakers. On behalf of the committee, I would like to say once again, thank you very much for sharing such a very insightful material to us. And also for the participants, thank you for joining this plenary session. And do not forget, we still have the parallel session for the presenter. I would like to remind all of the presenters that the parallel session will be started at 1 p.m. sharply. And I would like also to remind you that you may refer the technical details on how the parallel session will be done by seeing the document that already sent to you. And do not forget to fill the attendance list. So you will get the material and also your certificate. And on behalf of the committee, once again, thank you very much for Dr. Zulkifli, Dr. Gaber, and Professor Suranto, and also Professor Sejidan. And thank you very much once again. See you in the next event. And do not forget, after the plenary session, we still have a best paper announcement. On behalf of the committee, the Chinese Sea, sign out and have a good day, stay healthy, and hope to see you in the next event.
Thank you.
Thank you for inviting me.